Good morning to all the students of class 8. So today we will start from page number 46, J.J. Thomson's model of an atom. J.J. Thomson proposed his model of an atom in which small negatively charged particles called electrons are embedded inside a sphere of uniform positive charge. He compared the structure of an atom to the Christmas pudding in which the raisins are electrons that are embedded in a spherical pudding. According to J.J. Thomson, an atom has a sphere of positive charge in which protons are present. The negatively charged particles called the electrons are embedded in this positively charged sphere. The positive charge the positive charge due to the protons and the negative charge due to the electrons balance each other, making an atom electrically neutral. Now, in this J.J. Thomson's model, all the 3 points are very important and you have to learn all the 3 points. Okay. Next is very important, Ernest Rutherford's model of an atom. Learn the date also, 1911. Ernest Rutherford, a former student of the J.J. Thomson, conducted a series of experiments to explain the structure of an atom. On the basis of his experiment, he proved the Christmas pudding as suggested by the J.J. Thomson is incorrect. So, when he proved incorrect, what does he suggested? Rutherford conducted that alpha particle scattering the experiment which is discussed here. He observed that most of the alpha particles passed straight through the gold foil undeflected. Okay, and a small number of alpha particles were deflected at small angles while some were deflected at large angles. A very few alpha particles bounced back just like a ball hitting the wall. Okay, so here the question may comes that what does the Rutherford observed in his experiment during his experiment? Okay, and then the question will come that what does Rutherford actually come up to the conclusion? As the atoms of the gold foil allowed most of the alpha particles to pass through them, he concluded that an atom has a lot of empty space in it. As a small number of alpha particles having a positive charge were deflected, he concluded that there is a center of positive charge inside the atom. Okay, which will be called as nucleus. And as like charges repel each other, we all know that as like charges repel each other and the positively charged particles are repelled by the positively charged center inside the atom. Okay. A very few alpha particles bounced back. He concluded that the central core is hard and dense and is very small as compared to the size of an atom. He named the small, dense, and positively charged central core of an atom as a nucleus. As I have already said, that in the middle, whenever there is a positive charge, he called that nucleus. And surrounding the nucleus there were electrons. Okay, and on the basis of his observations and conclusions, Rutherford suggested a model of an atom. According to the model of an atom, each atom consists of a small, dense, and positively charged central core called the nucleus, and the protons are inside the nucleus. The protons will be inside the nucleus and the protons will be denoted by plus, and the electrons will be outside the nucleus, which we will denote as E minus. Okay, and the nucleus is surrounded by a large number of empty space in which negatively charged particles called electrons are moving at a high speed in circular path. Now, very very important, the drawback of Rutherford's model of an atom. Rutherford suggested that the negatively charged electrons move in circular orbits with the greater speed. Maxwell, however, challenged this observation. He was another scientist and he challenged him. He argued that according to the radiation theory, charged particle moved with greater speed in circular orbit emit energy in the form of the radiations. And since electrons are negatively charged particles now, and they are also moving at a high speed in circular orbit around the nucleus, So they must release the energy continuously in the form of radiations, and as a result of the reduced energy, the electrons must come closer and closer to the nucleus and ultimately fall into the nucleus, taking a spiral path. As a result, the atom should collapse then. This was a drawback of Rutherford's model of an atom. Okay. Now, Neil Bohr also tried to form the atom, tried to explain the model of the atom. What he had said, Neil Bohr explained the limitations of the Rutherford's of model of an atom. He explained that even though the electrons are moving at a high speed around the nucleus of an atom, they do not lose energy. The electrons revolve around the nucleus in fixed orbits. Each orbit has a different radius and a definite amount of energy, and thus electrons in an atom are moving, but the energy of the electron remains stationary. That means it will remain still in an energy level or fixed orbit. And what does he said? Each atom is made up of small particles called the protons and electrons, which Rutherford also concluded. But the protons are the positively charged and the electrons are negatively charged particles. And in the center of every atom, there is a positive core called nucleus. It also, Rutherford had said also, the nucleus of an atom contains protons, and the negatively charged electrons revolve round the nucleus in fixed circular paths called the shells. And these shells are represented as KLMNO or 1, 2, 3, 4, 5. Okay. And in the next page, each shell can hold a number of electrons, and for example, first energy shell can have a maximum of 2 electrons, and the second energy shell can hold a maximum of 8 electrons, and the third energy shell can hold a maximum of 18 electrons, while the fourth can hold 32 electrons. When one energy shell is full, a new energy shell will be started. Okay, and each shell will be associated with a fixed amount of energy, and the mass of an electron is negligible as compared to the mass of an atom as a whole. And the energy shell closest to the nucleus, that is K shell, possesses minimum energy. So here you have to rate any 5 limitations. Okay, any 5, whatever you like, rate those. Okay, so today we will read up to here only. Thank you, students.